The wind is one of nature's powerful sculptors. In sandy areas, the wind, whipping across the landscape, creates sand dunes of all shapes and sizes. Sandy areas are often very dry. Across one such desert in Colorado, the prevailing wind flows eastward, picking up sand along the way. When it reaches the mountains, the wind slows down as it moves up the mountain slopes. So the wind drops its load of sand, and it collects at the foot of the mountains. At Great Sand Dunes National Monument, you may visit these great mounds of sand piled up by the wind. Farther to the west, volcanoes spewed great clouds of ash and dust into the sky. Today, the volcanoes are quiet, and the ash formed from molten rock lies over the surface. For the last 1,000 years, the wind has been sorting the volcanic debris, carrying away the smaller grains, and leaving the heavier ones. Along many coastlines, products of erosion from the mainland are also sorted by the wind and waves into tiny particles that form beaches. One such sandy zone occurs here on the Outer Banks of the Carolinas, where the barrier between land and sea is a chain of islands formed primarily of sand. Shifted constantly by the wind, the barrier island is a very temporary kind of land, held in place only by the few plants hardy enough to survive the salt air, water, and shifting sand. In areas like this, quartz is by far the most common material because of its hardness and resistance to abrasion, and because it doesn't easily react to form new chemical compounds. Perhaps you've noticed that the word sand has nothing to do with composition. It simply indicates size. Sand grains range in size from 1/2 to 2 millimeters in diameter. The grains may vary in shape, but the battering they take as they are blown about usually knocks off their rough edges, leaving them round and polished to a frosted finish. If you visit a sandy region, the most obvious feature will probably be large mounds of sand called dunes. When some obstruction breaks the wind, sand piles up and a sand dune is formed. Along coastlines, sand fences are often used to aid the formation of dunes as a natural protector of the shoreline. As the pile of sand grows, it begins to serve as its own obstruction. In all dunes, a gentle slope develops facing toward the wind, while a steeper slope forms on the protected side of the dune. If you stand on the windward slope of a dune on a windy day, you can feel and see the sand in motion. As the wind blows across the sand, some grains are lifted into the air, but gravity pulls them back toward the surface. When they strike the surface, the force of their landing may knock other grains up into the wind stream. So if you watch the sand carefully, you will see that sand grains move in low, curved paths. The leaping sand grains may also move larger grains when they strike one another. Such large grains tend to creep up the slope, moving much more slowly than the bouncing sand. So they are often left behind, forming layers that protect finer sands below. The impact of bouncing sand grains also forms small waves or ripples on the surface of the windward side of the dune. If you look closely, you will see that they are miniature sand dunes formed on the larger dune surface. As sand moves up the gently sloping windward side of a dune, it finally reaches the crest. There it blows over the top and falls out of the wind stream, lodging near the top of the dune's steeply sloping lee side. In time, the slope becomes too steep, and gravity causes sand to slide down the slope until the angle is reduced and it becomes stable once more. Over a period of time, this dune will move slowly in the direction of the prevailing wind. When there's enough sand available, dunes like this may reach a height of 30 meters. With a steady prevailing wind, the entire dune may move as much as 15 meters a year. Given enough time, a large dune can easily overrun anything in its path. Stark trunks, standing now like ghosts among the dunes, are the remains of cedar trees which flourished in a maritime forest about 100 years ago. Great hills of sand buried the trees, leaving the wind to slowly uncover them. The sand at the water's edge is at the mercy of the waves, constantly shifted back and forth. The beach supplies the sand, with which the wind builds a low ridge called a foredune that is a protective barrier against the waves. Where enough moisture is available, the dunes are generally covered with sea oats and other hardy grasses. Protected from erosion by this carpet of living plants, the dunes become stable. In other places where the grass cover has been broken, wind may rip sand away, forming a blowout. Further downwind, a dune shaped like a horseshoe may form as sand lifted from the depression falls to earth. Where the wind shifts widely from day to day, small, irregular, mound-like dunes may form a sand sea. In many areas across the country, such sandy hills are covered with grasses and serve as pastures. But where grass does not hold the sand, it moves with the wind, forming layers in one direction today and another tomorrow. The varying wind builds crossed layers of sand that occasionally can be seen exposed in the side of an eroded dune. The same kind of crossed bedding formed in dunes millions of years ago is preserved in the sandstone cliffs of Zion National Park. Then, as now, the wind shifted and changed constantly. Sandstone here and in other places around the world is evidence of ancient deserts and beaches that have hardened to stone and become a permanent part of the landscape. Today, the wind works as it always has, eroding in one place, building in another. Around the world, wherever dry, loose, sandy material is available, the wind is a major force involved in reshaping the land.